Hi, this lesson is to teach you about dimensional analysis. So I'm just going to do a few examples. So dimensional analysis is a method of problem solving using conversion factors and setting those conversion factors up as fractions. So for example, if we say that 12 eggs is equal to 1 dozen eggs, that's a true statement, right? So there's 12 eggs in 1 dozen. Or I could say 1 dozen equals 12 eggs. I could say it either way. In dimensional analysis, we're going to use these conversion factors, but these equalities, we're going to put them as fractions. So I could say, for example, there's 12 eggs in 1 dozen, or I could write this as 1 dozen eggs is 12 eggs, right? It's the same thing, just we know that 12 is always a dozen. So we can use this in whichever way we need to or want to. So I could use this to solve a dimensional analysis problem. Let me erase this really quickly. So let's say that I'm having a big old party and I invited my entire extended family, and I'm trying to think of a valid problem. So let's say that I am having a party to feed my entire extended family of 107 people. This is a brunch party. Let's say that I'm having a party, I need to feed 107 people breakfast. Let's say I have lots of pancakes and I'm not worried about that, but I want to serve scrambled eggs. The average person, I'm going to plan for 2 eggs per person. So how many eggs do I need if I plan for each person to eat 2 eggs? All right. I like to, when I have problems like this, I actually like to underline the important points in the problem. So I'm going to say I'm having a party, I'm going to feed 107 people. I want to know how many eggs I need. So my answer is going to be in how many eggs do I need. Actually, let me change that because we don't usually buy eggs in dozens. So I'm going to say how many, I don't know if I can go back and edit this, sorry. How many dozen eggs do I need to feed all of these people? Yeah, I want to know how many dozen eggs I need because I'm not going to go to the store and say I need 200 and whatever eggs. So I do know that I'm feeding 107 people, but each person, I'm going to plan for each person to have 2 eggs. So sometimes it helps to kind of put this in first and say, I know my answer is going to be in dozens. How many dozens of eggs do I need? I'm feeding 107 people 2 eggs each. I'm just going to do that quick math in my head. So that's 214 eggs that I need. Now, I know that you could quickly do this in your head and you could just say, oh, I know, I'm just going to take 214 by 12 and that'll give me my answer. I understand that you're capable of solving this other ways, but you need to set it up exactly like this. This lesson is about learning that process and setting it up exactly how that process is. All right, so in dimensional analysis, we never divide. We always multiply by conversion factors. So if I have 214 eggs and I want to end up with dozens of eggs, and here's the trick. So this is 1 dozen. What you want to keep, the unit you want to keep always goes on the top. The unit you want to go away, so this is going to be 12 eggs. And this whole conversion factor is an equality. 12 eggs is equal to 1 dozen eggs. So to solve this, I'm going to take 214. Remember that a whole number is really a fraction over 1. 214 eggs, and I'm going to take 214 times 1, and that's the top, so 214, divided by whatever's on the bottom. 1 times 12, which is just 12. So I can do quick handy dandy math. Let me grab my calculator really quick. So if I take 214 divided by 12, it equals, I know this is messy, 17.83 dozen. So obviously I'm probably not going to buy part of a dozen, so I would round it up to 18 when I go buy my eggs. But this tells me I need 17.8 dozen. And again, I don't want to see you doing this. I already know how to find the answer, blah, blah, blah. No, you have to set up exactly like this so that eggs, I have eggs in the top, I have eggs in the bottom. So eggs cancels out, and I'm left with dozen. That's the unit that didn't cancel out, is dozen. So this is how we solve dimensional analysis. No shortcuts, no just doing this and dividing. That's not what we're looking for. Let's do one more example that's maybe a little bit. Here's another common problem we can solve using dimensional analysis. I am driving to Fargo, which is 126 miles from my home. I'm driving at a speed of 60 miles per hour. How many hours will it take me to get there? So I know my answer is going to be in what? How many hours? That's what I want to know. I'm driving at a speed of 60 miles per hour. I'm driving a total distance of, I want to know in 126 miles, how long is it going to take me to get there? So I will start with 126 miles. So I don't really have an equality in there. What I do have is this 60 miles per hour. 60 miles per hour really means you're going to go 60 miles in 1 hour. So that actually is our conversion factor. But I can flip it whatever way I need, remember. I could put hours on top or miles on top. Well, it looks like I need to end up with hours. So I need to put hours on top because I want to, what I want to keep goes on top. 1 hour, I will travel 60 miles. So just ballparking this, it looks like I'm going to have just over 2 hours, right? So 126, remember this is a understood fraction over 1. Miles is going to cancel out. I'm left with hours. So I'm going to take 126 times the 1 hour, which is 126, and then divide it by 1 times 60, which is just 60. Oh, I have to do my math one more time. 126, I have fat fingers, what do you know? Over 60, 2.1 hours. 2.1 hours I will be in Fargo. That's dimensional analysis. Let's do one here really quick that's going to take maybe a couple of conversion factors. Let me erase this. All right. Let's say that for some reason I have to convert miles into yards, and I want to know how many yards are in 5 miles. Looking at the conversion factors that I'm given here, I really don't have one that goes directly from yards to miles. I do have a conversion factor that goes from feet to yards, and I have a conversion factor that goes from feet to miles. So remember, I can write this as, whoopsie, 5,280 feet. Sorry, this stylus does not work well. Over 1 mile. Or I can flip this the other way. And this one I could say 3 feet in 1 yard. And again, I can flip this and use this however I want. I do know I want to end up with yards, and I'm given miles. So that gives me a starting point and an ending point. So I want to end up with yards. I'm going to start with miles. My first conversion factor, I know I don't want to end up with miles. My first conversion factor is going to be to get rid of miles. So there's only one conversion factor that has miles in, and that's this one right here. So I'm going to put feet on top, 5,280 feet in 1 mile. So now, if I stopped right here, miles would cancel out, and I'm left with feet. But I don't want that. I actually want to get all the way to yards. So right now I have feet on top. I know to get rid of this, I need to put feet on the bottom and find a conversion factor that has yards on top. I'm right here. So 3 feet in 1 yard. I need to erase this and make some more room here. So 3 feet in 1 yard. Now I can do my dimensional analysis to solve this. I multiply everything on top together, and then I divide it by everything on the bottom multiplied together. That's how I'm going to solve this. So I take 5, I'm going to grab my calculator, 5 times 5,280 times 1, which we don't care about, right? So 26,400 if I multiply all the stuff on top, and then I'm going to divide that by 1 times 3, which is going to give me a total of 8,800 yards. And then I always say, does that make sense? Well, yeah, you have 5 miles and you have a lot of feet, and we know there's 3 feet in a yard. So just quick ballpark, 5 miles times, let's just say 5,000 feet would be, 25,000. And then we're only dividing it by 3, which is a pretty small number. So yeah, that actually seems pretty reasonable. All of my units cancel out. So feet cancels out, and I'm left with yards. Perfect. And that is how you do dimensional analysis. When you have more than one conversion factor like this, I want you to put this in one big, long problem like this. Don't try to do 2 separate calculations and solve halfway through. I didn't solve halfway through. I took 5 miles times 5,280 feet times 1 yard. These conversion factors are all in a line. I didn't split them up and solve halfway through, and I don't want you to do that either. So I want you to try to work through the problems on the worksheet, and we'll talk about it when I get back.